Hello and welcome to today's module, Introduction to DMAIC Process Part 2, Measure Phase.
Hello, ladies and gentlemen. Today we are going to talk about a 5-step improvement process known as DMAIC. DMAIC stands for Define, Measure, Analyze, Improve, and Control. Measure is the second phase of the DMAIC process. In this phase, we measure the process performance in its current state in order to understand the problem. The key output is a focused problem statement. Through data stratification, we are able to determine which areas of the process need to be analyzed in the next phase. Measure phase is 2 to 4 weeks in duration. To ensure good brainstorming during the analyze phase, all team members should be actively engaged at the Gamba during data collection. During the measure phase, the team spends the majority of their time at the Gamba. The 4 key steps in measure include: 1. Design the data collection plan. Identify the data collection points, what type of data will be collected, how it will be measured, and team expectations. A. Create a process map of all of the activities required to convert raw inputs into the finished output. B. What are the critical factors of the process? See the critical to quality diagram created in the define phase. C. For each point along the path that a deviation can occur resulting in a defect, list this as a waste point on the process map. D. Create the data collection plan based on the process map waste points, critical factors identified in the define phase using the CTQ, and brainstorm additional factors. Measurement systems analysis. For every measurement point, ensure the gauge reads the value accurately and precisely. For instance, a common gauge in process capability studies is a checkweigher. The checkweigher must be both precise and reliable. Prior to starting a process capability study, verify the checkweigher is not contributing significant weight variation between cup to cup by performing an MSA. In MSA, verify the gauge has high accuracy. When looking at several data points, accuracy refers to how close the data average falls within the known standard. A process with high accuracy will have most of the data points clustered around the target value. Whereas, in a low accuracy process the data points are away from the target value. Precision. When looking at several data points, precision refers to how close the data points falls in relation to each other. In other words, what is the variance? A high precision process will have little variance between the individual measurement points. Therefore, the data points will be clustered around each other. Measurement systems analysis. A gauge should have both high precision and high accuracy. If the gauge fails for either, the data collection should halt. Calibrate the gauge. If it can't be calibrated, then the gauge should be replaced. Data measured by a bad gauge is bad data, and should not be used for analysis. 3. Perform process capability studies and data collection. 4. Perform data stratification to derive solid focused problem statements. Move on to the next phase by getting approval from management. At the end of the measure phase, you will have completed several activities in order to complete the following tasks and objectives: focused problem statements, measurement systems analysis, gauge R&R, Type 1, bias and linearity, process capability studies, Lean Six Sigma metrics, DPO, DPU, DPMO, and Sigma level, and revised project charter.